In this video, we're going to be taking a look at your virtual machine environment that is accompanying the Interbus field test, and we'll go through the basic steps of performing the conversion. So, as you may have seen in the PPT that was out, that there's a number of steps involved. It starts, in this case, with a PL7 project that then gets imported into Unity Pro, and then we run a utility on it, step 3, that pulls out the Interbus configuration for later use. Then we use the UMAC tool, and then we install in the configuration the PMEIBS Interbus hardware. And then in the next step, we run a second utility which inserts the Interbus configuration that was collected in step 3 into the new device DDT and DTM environment of the PMEIBS. And then finally we open our application as M580. So I'm going to step through the various pieces of this process. First, a word about your virtual machine. You may notice that there's a feature in the virtual machine that allows you to move files between your host PC, your desktop, and the virtual environment. And I've kind of pre-configured it on the virtual machine. So, for example, if you launch your virtual machine settings tab, and you go to Options, shown here, and if you scroll down, you'll see Shared Folders. I've already created a shared folder, and it may be disabled on the virtual machine for simplicity. But if you create a folder off of your C drive called VM Share, and then simply check this Always Enabled, what that'll do is it'll create a virtual folder or drive. In this case, it's a Z drive in my virtual environment. So I can point to that, and I can see the contents like a VM share. And if I scroll down through my field test example here, I see the Interbus example that we're going to use today. Now, if I go to my regular desktop environment, I see the same file in the same location. So this is the feature in the virtual machine environment that allows you to move files between the virtual machine and your external or host PC. So to get started, with this Interbus example, you can see it's an STX file, which is a native format for PL7. So we're going to take a look at it in PL7. So we're going to open up the file. And here I'm going to scroll to my shared folders, the virtual share, VM share, navigate through the tree to my file. And it opens up. And in here, I can see my hardware configuration shows an IBY.EXE Interbus card in slot 4. There's no local I/O in this rack, small rack, it's only 4 slots. I have the power supply, CPU with an ETY port, and the IBY.EXE. If I double click on the IBY.EXE, I can see the devices configured in Interbus, and it seems that this particular application has a SVC file. Now the SVC file comes from the Phoenix CMD software tool, and that is also to be found on your virtual machine. So the Phoenix CMD software was what a lot of customers used to create the original Interbus configuration. So here you would define your Interbus end devices and your process data, what type of module it is, how many words in, how many words out, PCP data, and things like that. And then you would just export this to a file, and then when you did that, write as ASCII file, see, Interbus data, SVC file here. So you would write out that ASCII file after configuring your Interbus network using the Phoenix CMD software tool. And then by clicking here, you would just browse and select that SVC file, and it would bring it into the IBY.EXE environment. There's 2 choices. You have 128, well, there's actually 3, or 242 words. There's only one size for the PMEIBS, and that is the largest size. It's a full 242 words. And so I can see here I got, probably about 22 devices. These are all station buses, so to speak. So you have ID device, 4, 5, 6, 7, 8, and how many words of I/O that they support. If it's an intelligent device, such as a drive or something that's controlling something with parameters, you may find that it has PCP data associated as well. So customers, will configure these devices in the CMD software, then bring it in here, and then it becomes stored as part of the Unity project. So even though the CMD tool is there in the virtual machine, you don't necessarily need it. And the reason is that the full Interbus configuration is actually stored in that XTX file. It's stored in PL7. And so that means those utilities that we're going to be using, we'll be able to pull out that information and then reconstitute it on the PMEIBS. So to get started, what we want to do is export this as an FEF archive. So we're going to export this, and we're going to stick in the same folder. And it's highly recommended you do one project per folder, because as you'll see as we go through the process, it's going to create a number of files and even some folders. And to avoid any naming conflicts, create a separate folder for each of the projects that you're going to modernize to M580. So here we'll give it Interbus example, and it's an FEF file format. Click Save, and your progress is down here in the lower right-hand corner, and you can see it just wrote out that file. So if we take a look at our browser here, and then just refresh, just go down and up. There we go. So we have an Interbus example.fef. This is what we're going to be opening in Unity Pro, because as the first step is to assess your application, see what you got in the PL7 environment, and then bring it into Unity Pro so we can continue the modernization. So with Unity Pro, I'm going to open up that archive. So I'm going to browse on my local PC to drive C, and then actually I'm the virtual PC. And I just scroll down to Interbus FEF, set my filter in Unity Pro to FEF, open, and then open it up. And here it's using the Unity embedded converter for PL7. There's embedded converters for concept and for 984 ladder, and there's also one for PL7. So this may take a few moments, but what we want to do at this stage is once we get into Unity, it'll come across in general 99 to 100% all the time. It's usually quite reliable. And you might have to import any custom DFB libraries that the customer might be using. We've seen customers that have their own DFB libraries, and we have to update our Unity with that. In some cases, they may have locked DFBs. You'll need to get those unlocked before we proceed further. And so here we can see we have a similar configuration here. The only real difference being that it changed the processor reference. So in PL7 Pro, we had a TSX 57 3623 CPU, and in Unity Pro we got a 3634 CPU. So sometimes if you have trouble bringing it from PL7 into Unity Pro, try going back and changing the CPU in PL7 because it has to translate to a Unity ready CPU. So if we look at our application, we can see we got a little bit of logic. By the way, it seemed to come in here with no errors and no warnings. So we got a little bit of logic going on there in ladder diagram. In terms of variables, we have some variables that we can see here are Interbus variables because they're topologically addressed at 0.4.0.0. So rack channels, rack slot channel drop, etc. All that. So we have about a dozen or so variables that are assigned to that Interbus module, and they're used in the application. Sometimes they're direct reads to these topological addresses. Other times they might be using send request or read var, write var to be able to read and write Interbus variables. And so, we're going to be seeing how these evolve through the process, but this will keep all of your variables. And instead of pointing them to a physical location, the topological address, it'll point it to the corresponding entity in the device DDT. So we'll do a build on this application to see if there's any errors we should clean up. Always a good idea to try and keep it clean as you go through the process instead of compounding errors. And it looks like we, over in the lower right hand corner here, we got a clean build. So what we're going to do here for the next step is to, we're going to export this, export the project. Once again, I'm going to browse to my shared folder, navigate, and here, oops, this is the one. I'm going to call this Interbus example. Okay, and I'm going to export that as a ZEF file. Now, the first important step here with the utility is some people have had some issues running the utilities that come with the PMEIBS inside the virtual machine. I'll point them out as these. So, for example, if you go to inside your virtual machine to start, go to the Niobrara folder and then to the PMEIBS subfolder. And you'll see two utilities, Convert IBY and Extract IBY. Extract IBY is when we pull it out of the original configuration. In other words, what we're looking at here. And then we go through the UMAC step. And then afterwards, we use Convert IBY, and it takes all those variables accrued in the Extract IBY and transplants them and adds the linking code to link the device DDT elements. Some people have had some trouble running it inside the virtual machine. So I put the installer in the box as well. So the PMEIBS.EXE, that's a setup file, so you can install it in your host machine. So I'm going to run it on my host machine. So if I just go to my host desktop, programs, select Niobrara, PMEIBS, extract IBY. So I'm going to select this first utility. And what I'm going to do is open up that ZEF archive I just created in Interbus in Unity Pro for the Interbus project. So here's my Interbus example.zef, and I'm going to launch this. And we're going to see this folder start to grow as more files and other subfolders get added to it to be able to develop all of the material it's going to need in the later step. So let's go ahead and run the utility. Now you'll see a number of DOS shell windows come up, and it may take 20 seconds or 30 seconds or a minute or more, depending on the size of the application. You can have up to 2 IBY modules in your premium rack. Correspondingly, you can have 2 PMEIBS modules in an M580 rack. The legal slots for the PMEIBS are either in your local rack that is a dedicated Ethernet slot, or as a remote I/O drop. It can exist in an RIO drop or Ethernet remote I/O drop. It cannot exist in an extended rack. So here we see we have success. And we can see from the summary screen that it goes through and looks, and it found 15 topological input variables, 42 topological output variables. It didn't find any instances of topological channel variables. Sometimes customers will use the PLC stat function. You can use a PLC stat function to look at the module, in other words, a module diagnostic health. And then you can have a second instance in a PLC stat to look at the channel health of the Interbus devices. This application doesn't happen to be using them, but if it were, these utilities will also adapt that to a DFB. So in terms of the variables stay the same as they are in the application. So whatever they named it for module or channel, that'll get translated over into M580. So they'll get the same data. It is just being handled a little bit differently. It's either using a DFB. If they happen to be using send request or read var or write var functions, what's going to happen is going to replace that with a DFB using data exchange. So it performs all the same functions, it just manages it a little bit differently, but the solve is identical. So now if we go look at our folder, we can see that it's gained some additional weight. So now we started with Interbus example.stx, and then we created that the FEF file we exported from PL7 Pro. Then we imported that to Unity Pro, and we created a ZEF file. Then we ran the utility, and you can see that the utility did two things. It created a new ZEF file that does not have the premium IBY module, and it also created an archive folder. In the archive folder, we have a number of different things. So we have the SVC file. So the Interbus example SVC, that would be very similar to the SVC file that was originally uploaded to PL7 to create the Interbus configuration for the premium in PL7. Then we have our input variables and output variables. So it's making a list of all the input variables, and so you can see, the topological address and the input word, and then similarly with the output variables. it's creating a list of all of your output variables. And so it's tracking all that information. So the folder has grown a little bit. We've got our intermediate files, which we're going to leave there. We've got a new IBY file, and that's the one we're going to be using for the UMAC tool. So let's go ahead and launch the UMAC tool. So Unity to M580 application converter. It is installed on your virtual machine. It's also available for download from schneiderelectric.com. If you do use the UMAC, you install it on your host PC, you want to take care for one thing. Up here in the upper right hand corner under About, if you see upgrade product and it is not grayed out, it means you're running the light version. There's two versions of UMAC. There's the light version and the standard version. And I recommend that you run the standard version to get all of the features of the UMAC tool so it can make adaptations for, let's say double registers or I/O scanner or unsupported data types. So for example, in Premium, you could have %MF, floating point, double register. You could have %MD, %KF, floating constant, and %KD. Those are not supported on M580, but the UMAC will make those adaptations for you. But you will need the standard version. So you want to make sure that you go through the activation, contact Modicon Migrations at schneiderelectric.com for any information that you might need, and get an activation code so that you have the full version. And the standard version, once again, this will be grayed out. So we'll get started. We have a premium application from Unity, obviously, and then we're going to just skip through this screen, which kind of shows you how to prepare it if necessary. But since we have no local I/O, we really don't have to make that kind of adaptation. So let's browse to our project. So here we have our Interbus example, IBY.EXE. So that's the one we just created with the utility from NR&D, the extract IBY utility. So let's open this up, and it's going to go through an analysis step. And we can look at the detail as it goes along. It's generating some report information. Okay. And if we look at the report, for example, we can select analysis report, and it'll kind of give us a sense of what changes it might have to be made. And so under this analysis report, it's going to give you a nice summary, and it's going to show you the setting like cold start, warm start. So the CPU itself, the time bases, things like that. So it'll kind of tell you what it found about the application. So that could be kind of informative. I would probably keep that for your records for customer modernization. So now we select Next. And here we can select amongst various options, but in general, you're going to accept all of the defaults. The only thing I'll really want to change here probably is the CPU. So since I'm using a 2040 CPU in my rack, I'll select 2040 here. I could always go through it with the default selection of 6040 and then change the CPU if I wanted to. But for the purposes of this test, I'll just make a little convenience and change it here. And now I go through the convert step. So you can see the input file, Interbus example IBY.EXE. Let's go through the conversion, and we can follow along with any detail. So this can vary depending on how many adaptations it has to make. What the UMAC is doing is taking that ZEF. That ZEF is actually an archive of XML files. And the UMAC is going in and making an analysis of those files. It's looking for any adaptations that would have to be made. It's also moving the platform from the premium hardware configuration to M580. And once it does that, we'll have a look. So we can see that our conversion completed successfully. So we just click OK. Very important step here, save as. Otherwise, it won't save your work. So you got to be sure, accept the acknowledgments and warnings and things like that. And we can see that our file name gained a little weight. So today, or now, it's called Interbus example _ IBY. That was added on from the extract IBY utility. And then M580, that was added on by the UMAC utility. And so we've saved it, and we'll click Finish. And so now we can see we have a new utility here, and we can open up that file and see our device in M580. So continuing on, we have Interbus example underscore IBY space hyphen space M580.ze. So that's the file we're going to be using in Unity Pro or actually control export. So I'm running a control export here. So I'm going to, and again, this is on my host PC, so I'm just going to browse my way to VM share and to navigate the tree here for my example, set my filter to ZEF, and so I'm going to select the Interbus example IBY M580. And so I'm going to open that up in control export. The virtual machine is Unity 12, I believe. The PMEIBS will work with pretty much any version of Unity after version, I think it can go back as far as 8, but I recommend going to at least 11. So it's not locked into any particular version of Unity. It has to be able to support DTMs and device DDTs though. So if we take a look, first thing we want to do after we see our M580 bus here is we want to install the hardware. So one thing, for convenience, I'm just going to shorten up this rack because we had a small rack to begin with. So we have a CPU and power supply. The PMEIBS does not have to go in the same relative rack position because the second utility, convert IBY, is going to find out wherever it is in the local rack or in an EIO drop, and then glue those variables or attach those variables to the device DDT and DTM for its new location. So it doesn't have to go in the same in slot 4. So in this case, we'll select it because there is no slot 4 technically. I mean, you got slots 2 and 3. So I'll pick slot 2 and insert the PMEIBS hardware. So we double-click to select a new device, and then we just select third-party products because this is from Niobrara, Research and Development, not Schneider per se. We select the PMEIBS 0111, and that installs the hardware. The next thing we need to do is install the DTM. And so if we go to our DTM browser, and we right-click on our CPU and select Add, it brings us a list of standard DTM devices that are included with Unity Pro. Now, we've added hardware support with the CPX file. That was covered in that PowerPoint. We also added the DTM to the library, so I have slides on that. So if you need information on how do I add the hardware to the pick list so I can put it in the rack, and then secondly, how do I add the DTM so it becomes selectable in the DTM list, that's covered in the PPT. So you can just search on CPX or you can search on DTM in that PPT. It will bring you to those slides. So we scroll down, let's say a few pages here. Okay, that was about 4 pages, I guess. And then PMEIBS and the versioning, yeah, that may vary, at final release. Click Add DTM, and we'll give it a name. So I'll give it a standard name like PMEIBS 01, and just select OK. And now one other thing we want to do, because in terms of the configuration, and this is really important, the PMEIBS doesn't really rely on external software for its configuration. The utilities help modernize what you had before on the premium platform, but the configuration is actually stored as part of the Unity project or Control Expert project, and the way it does it is using faulty device replacement or fast device replacement, FDR, on the CPU. And so when you make a change to the configuration in the PMEIBS, it backs it up with the PRM file to the CPU. And then by the same token, when it boots up, it collects its configuration from the CPU. So what we want to do is kind of sync where it is in the rack and its client unique identifier. That's the DHCP option used in FDR. So okay, so what we do here is we have to make sure that the address server is in sync with the location. And so we see that it is currently in slot 2. So when we click Open for the DTM for the CPU, and we look at the device here, we can see that you have a properties page, but importantly you have an address setting, and this is where FDR and DHCP come together. So here we have the a name M580_01 indicating slot number, and then the DTM name that I gave it. So what you want to do here is I want to change that from 01 to 02. That reflects slot 2. And so that's an important step to make sure the PMEIBS collects the right FDR configuration when it boots up. So I say OK, and that saves off. And so we don't have any much more to do really at this step. So what we're going to do is we're going to move on to the second utility to insert the variables from the premium environment and link them up with the device DDT. So to get ready for that utility, convert IBY, the first thing we want to do is export the project. So we can do a build first, just to try and keep things clean. And we can see we got an error here. And let's take a look at this error. And so the reason we're getting an error is the UMAC has added a file. And so this file, it says converter error for projects with more than one task. It's telling you about push-pull and DFBs, and that has to do with register alignment. But in general, this is essentially a message to you, the operator, that the UMAC tool has done some things with your application. And so it wants to force you to actually read this note. And then you can either add parenthesis asterisk at the beginning and asterisk parenthesis at the end to make it, a valid ST statement in Unity, or you can delete it. So for simplicity, it's just 2 lines. We understand what it's doing. So I'm just going to delete this section, and then I'll try my build again. So if you see files like that, because you may see them related to unsupported modules, related to Ethernet I/O scanner, things like that. So those are things that it's for your information, and then you can acknowledge it and delete it, or you can edit by making it a proper ST statement and save it in the application. And so we can see that we have it's built here. So now that we have a good application, let's just go through and export this once again to the file format ZEF so that we can use it for our second utility. So under this PC, I'm going to scroll down to drive C because I want to save it in the same place, save it to my VM share. Oops, went one level too far there. Example. And so we had Interbus example, IBY, M580, and I'll say PMEIBS, just to indicate that this version of the project, I've added the PMEIBS hardware and I added the DTM. So I'll click Export. Very good. So that is exported, and so we can see our folder just continues to grow here. And so this is the file we just created, and this is the one we're going to run that utility on. So again, on my host PC, I'm going to go to Programs, I'm going to go to Niobrara, PMEIBS, I'm going to run the Convert IBY utility. So I launch our utility, again, a very simple shell. What I'm going to do is take and launch this and point it to that file that I just created. So File, Open, and this one here, Interbus example underscore IBY hyphen M580 PMEIBS. So let's have it work on that. And once again, this is going through and it's parsing through the XML files, and it's inserting those variables, and it's attaching them to the device DDT. It's adding any supporting logic, and so it's kind of gluing, binding the whole thing together. So we can see we have success here. And it gives a little summary screen here. So it had found it originally in slot 4, now it's in slot 2. So we have a new file, once again, and you can see that what it did is it added IBS to the file name. So once again, the file count continues to grow. But this way, by saving these files off, you don't have to start all over at the beginning. You can pick it up and correct any errors along the way, choosing the appropriate file. So here I'm going to open up this file, PMEIBS. So I'm going to close down my old file. I'm not going to save changes to this. And I'm going to open up our new file that we just created. So once again, I'm going to set my filter to ZEF. and I'm going to look for the one that was just created by the convert IBY, and that one is with the IBS suffix on the file name. And click open. And it'll take a few moments as it goes through. Okay, very good. So now we should have our PMEIBS installed. This utility also added some logic. So if we take a look at our logic, you can see mass pull section and mass push section. That was added by the UMAC. That is not with these utilities. So that's a UMAC feature. But you can see it did add IBS in, IBS load, and IBS out. And so to just cover those, IBS in, that's where it's reading the inputs. So it's taking the values from the device DDT of the PMEIBS and copying to those named variables we saw in the original application. Okay, so it's going through that. If we look at IBS out, it's doing the exact opposite. So you can see that it's going the other way. So from here, it's device DDT over to variable, and then it goes through the application, solves this variable name, right, these variable names, and then at the end, it takes and copies them to the device DDT, so it gets written back out on the Interbus. So it goes one way at the beginning to read inputs, solves as an unlocated variable, and at the end of your application, it reverses and it copies the newly solved variables to the device DDT. It also created a section called IBS load, and this is the configuration for all of your end devices. And so you could copy and paste, but in general, they're stored as like from our station bus number 1, station bus number 2, number 3, and so on and so forth. If there's the same type of device, the same drive or the same I/O, they'll have very similar profiles. The only difference is being the memory locations. We're adding a learning feature to the PMEIBS utility so that it'll actually go out and discover what you have in your Interbus network and create those profiles just to simplify managing those devices. So essentially, that's all the logic it adds. There were no DFBs to be adapted. However, that is documented in the PPT, Premium to M580, that's on the box for the field test. And so, we're going to go ahead and do a build, and this would complete our project. And we'll see if we get a clean build. And then we would be ready to deploy on a customer field test. Now, a field test is not production hardware or anything like that. This is best tested in a test environment. So try and get a clean build on an M580 processor. Try a little bit of I/O. Try and actuate things. And you can actuate them the same way you did before. So if your customer had an HMI that he used to actuate, say, a drive or an Interbus, he should be able to do the same thing because the variables are all there. The Interbus is managed by a new hardware, but fundamentally it's all as it was in place. So it's recreating the Interbus environment. In fact, the PMEIBS uses the same board set, the Phoenix board, because Phoenix developed Interbus, as the IBY.EXE, and then it uses the Ethernet backplane interface as a data board. But we can see that we have a built application here. So this brings us to the point where we can look forward to going ahead and working on our field test with our customer. Any questions, please send an email to me, Mike Roach, and to a copy to monoconmigrations@schneiderelectric.com. We'll respond as quick as we can. Thank you for listening.